You're going forward through time 1 second every second. Congratulations, you're a time traveler.
Time. It's what keeps everything from happening all at once, as the saying goes. It is the invisible thread that weaves the fabric of our existence, giving structure to our days and meaning to our lives. Every second we move forward from the past to the present and onward to the future. This relentless progression is something we all experience, whether we are aware of it or not. It is the silent companion that walks with us through every moment of our lives. We experience this movement as a constant flow, an unstoppable march toward what lies ahead. The ticking of a clock, the changing of seasons, the rhythm of our heartbeat, all are reminders of time's unyielding passage. But what if we could change that flow? What if we had the power to bend time to our will, to pause it, speed it up, or even reverse it? The possibilities are as intriguing as they are mind-boggling. What if we could travel through time, not just experience it second by second? Imagine being able to visit the past, witness historical events firsthand, or glimpse into the future to see what lies ahead. The idea of time travel has captivated humanity for centuries. From ancient myths to modern science fiction, the concept of moving through time has sparked our imagination and inspired countless stories. Stories of journeys through time fill our books, movies, and imaginations. They allow us to explore the what-ifs and the might-have-beens, to dream of adventures beyond the constraints of our temporal reality. But is time travel really possible? Can we ever hope to break free from the linear progression of time and navigate its currents at will? The answers lie in the realm of theoretical physics and the groundbreaking work of scientists like Albert Einstein. Or is it just a fantastical dream? A tantalizing idea that remains forever out of reach, confined to the pages of fiction and the screens of our favorite films? To understand the answer, we first need to delve into the true nature of time itself. What is time? Is it a tangible entity, or merely a construct of our minds? By exploring these questions, we can begin to unravel the mysteries of time and perhaps one day unlock the secrets of time travel. Time, the fourth dimension. We often think of time as a linear progression, a straight line stretching from the past to the future. But physicists see time differently. In the realm of physics, time isn't a line, it's a dimension. Just like we can move left or right, forward or backward in space, time is another direction we travel through. This concept, known as space-time, was first proposed by Albert Einstein. Space-time combines the three familiar dimensions of space, length, width, and height, with time, creating a four-dimensional fabric that makes up our universe. Everything that exists, every event that happens, is a point in this vast space-time continuum. The river of time. Imagine space-time as a vast flowing river. We, as travelers in this river, are constantly carried along by the current of time. We can move around within the river, changing our position in space, but we are always swept forward by the relentless flow of time. This analogy helps explain why we can't simply decide to travel backward in time. Just as we can't swim upstream against a powerful current, we can't simply reverse our direction through the dimension of time. The laws of physics as we currently understand them dictate that we are bound to travel in one direction, forward. The speed limit of the universe. It's a concept that has fascinated scientists and curious minds alike for generations. But our journey through space-time isn't as simple as floating down a river. Imagine a river that flows not just through space, but also through time. Here's where things get really interesting. Scientists have long pondered the mysteries of the universe, and one of the most intriguing questions is about the ultimate speed limit. According to Einstein's theory of relativity, everything in the universe is always moving at the speed of light. This isn't just a random number, it's a fundamental constant of nature. Yes, you read that right, the speed of light. It's approximately 299,792 kilometers per second, or about 186,282 miles per second. This speed is not just fast, it's the fastest anything can travel. Now you might be thinking, but I'm not moving at the speed of light. And that's a fair point. It certainly doesn't feel like we're zipping through the cosmos at such an incredible speed. And you'd be right, at least in the traditional sense. When we talk about speed, we usually mean our speed through space, how fast we move from one point to another. Whether it's running, driving a car, or flying in an airplane, these are all examples of moving through space. But there's another dimension to consider. However, we are also constantly moving through time. Every second that passes, we are traveling forward in time. and this movement is just as real as our movement through space. Einstein's theory tells us that our total speed through space-time is always the speed of light. This means that if we are moving slower through space, we are moving faster through time, and vice versa. The fabric of space-time is a complex and fascinating concept. It's like a giant four-dimensional tapestry that we are all a part of. Our movement through this tapestry is governed by the speed of light. Experiments like the light clock and thought experiments such as the twin paradox illustrate how time and space are intertwined. Time dilation, for instance, shows that time can slow down or speed up depending on how fast you are moving through space. As we continue to explore the universe and develop new technologies, understanding the speed limit of the universe will be crucial. It will shape our future in ways we can only begin to imagine. So, the next time you look up at the night sky, remember that we are all moving through space-time at the speed of light. It's a journey that connects us to the very fabric of the universe. This constant speed limit leads to some mind-bending consequences. The speed of light, approximately 299,792 kilometers per second, is the ultimate speed limit in the universe. Nothing can travel faster than this cosmic speed limit, and this has profound implications for our understanding of time and space. One of the most fascinating consequences is time dilation, a phenomenon where time actually slows down for objects moving at incredibly high speeds relative to a stationary observer. Imagine two identical twins born at the same time and sharing the same genetic makeup. One twin stays on Earth living a normal life, while the other embarks on a high-speed journey through space, traveling close to the speed of light. This journey through the cosmos will have a surprising effect on the passage of time for the traveling twin. According to Einstein's theory of relativity, time will pass slightly slower for the traveling twin compared to the twin on Earth. This means that while the Earth-bound twin experiences time at a regular pace, the spacefaring twin's clock ticks more slowly. When the spacefaring twin returns to Earth after their high-speed journey, they will be slightly younger than their Earth-bound sibling. This difference in aging is a direct result of time dilation, showcasing the strange and counterintuitive nature of time at high velocities. Time dilation isn't just a theoretical concept, it's been experimentally verified in various ways. Scientists have conducted numerous experiments to test and confirm the predictions of Einstein's theory of relativity. One of the most compelling pieces of evidence comes from atomic clocks, which are incredibly precise timekeepers. These clocks have shown that time passes slightly slower at higher altitudes, where the Earth's gravitational pull is weaker. This effect, known as gravitational time dilation, has been observed in experiments involving aircraft, satellites, and even the International Space Station. In fact, the technology we use every day, such as GPS systems, relies on an understanding of time dilation. GPS satellites orbiting the Earth experience both velocity-based and gravitational time dilation. Engineers must account for these differences to ensure the accuracy of the positioning data we rely on for navigation. The concept of time dilation has revolutionized our understanding of the universe and continues to be a subject of intense study and fascination. It challenges our intuitive notions of time and space, reminding us that the universe operates in ways that are often beyond our everyday experiences. As we continue to explore the cosmos and push the boundaries of space travel, the effects of time dilation will become increasingly important. Understanding these phenomena will not only help us navigate the vastness of space, but also deepen our appreciation for the intricate and mysterious nature of the universe. The idea of time dilation has led some physicists to speculate about the existence of particles called tachyons. Tachyons are hypothetical particles that always travel faster than light. According to the equations of special relativity, if tachyons exist, they would have to travel backward in time. However, the existence of tachyons remains purely theoretical. They have never been observed, and their existence would raise significant paradoxes and challenges to our current understanding of physics. So, if we can't travel backward in time with tachyons, is there any other way to break the time barrier? Unfortunately, based on our current understanding of physics, the answer is a resounding no. Faster than light travel, which would be necessary for backward time travel, is deemed impossible by Einstein's theory of relativity. The speed of light isn't just a speed limit, it's a fundamental constant in the universe. It governs the way information travels, and breaking that limit would shatter the very fabric of causality, the relationship between cause and effect. While the dream of time travel may remain elusive, our exploration of time and its mysteries teaches us a valuable lesson. The present moment, this fleeting instant in the grand river of time, is precious. We may not be able to change the past or fast forward to the future, but we have the incredible power to shape the present and influence the course of our journey through time. So let's embrace the present moment, for it is in the now that we truly hold the power to create our own unique path through the extraordinary tapestry of time.